I'm Fran.
And I'm Maximo.
And today we're going to be talking to you about Coalwood Creek.
Coalwood Creek is located in Coalwood, Vancouver Island, British Columbia, and it flows past Royal Roads University and Hatley Park.
It originates in the Humpback Reservoir, and then it flows into Glen Lake, into Coalwood Lake, and eventually into the Esquimalt Lagoon.
Today in this wonderful little video, not only are we going to be frolicking around a beautiful little forest and a wonderful creek, we are also going to be identifying and talking about some interesting features at the Coalwood Creek.
One of the first features we're going to be discussing is a cut bank, then we're going to be moving on to braiding and islands, and finally we will be discussing nick points.
Beam shakalaka. This is a map of Coalwood Creek and the land cover within the watershed. On a large scale, there's no braiding, but we'll talk about braiding on a smaller scale later. There is meandering at Coalwood Creek, however.
Here's a hydrograph for Coalwood Creek's stream discharge in 2023. However, this is a really weird hydrograph, so we made a few of our own.
It is made from downloaded stream discharge data from 2023. The maximum fluvial discharge in 2023 was 45.2 cubic meters per second.
But 2023 isn't very representative of the usual fluvial discharge for Coalwood Creek at all. What is more helpful is the mean monthly discharge for Coalwood Creek over all time.
The month with the highest average discharge is November, which makes sense because precipitation is highest in the Victoria area this month. That's followed by August, but this is because of just one significant outlier in the data.
Without outliers, discharge is relatively consistent seasonally, except in winter, probably because water is frozen at that time.
Coalwood Creek descends from an altitude of only 120 meters at Humpback Reservoir to 0 meters 7 kilometers later, where it flows into the Esquimalt Lagoon. This means that the average gradient of the stream as a ratio is around 1 to 58. This flat topography causes meandering on large and small scales, as seen in the video.
We walked upstream beside Coalwood Creek from where it flows into Esquimalt Lagoon up to College Road, observing the features of the stream along the way.
Let's start with our first feature, cut banks or undercut banks. Cut banks form on the outer curve of the stream opposite to point bars because the thalweg of the river hits the bank and erodes it until it becomes a steep vertical shape like a cliff. Undercut banks, like the ones we see if we look closely at these videos, form when the lower portion of the bank is eroded, forming an overhang. Eventually, the stream will undercut the banks so severely that the upper portion will fall into the river, adding to the sediment load of the river and potentially leading to aggradation.
We said we would get back to braiding, so let's talk about it. Rivers often braid when they have high sediment load, high discharge, and unstable point bars. Usually this happens in locations with steep gradients, but as we said before, Coalwood Creek has a very low gradient. What we observe here is temporary small-scale braiding because of the increased sediment load. It's fall right now, so we see a lot of organic sediment in Coalwood Creek from leaves falling off trees. This sediment usually gets stuck in the middle of a channel due to friction or an obstruction and builds up. This deposition creates islands in the middle of the stream, forcing the water to find a different path. The water reconvenes a bit farther downstream. Eventually, these leaves are going to break down and the channel will likely not be braided anymore.
We were lucky enough to discover multiple nick points along Coalwood Creek. A nick point is a point where the slope of a stream changes quickly. It can come in a variety of forms, but the ones we identified today were in waterfalls. Notice that the ground the waterfall flows over is rock, while the ground around it is softer soil. It takes longer to erode rock because its particles are more strongly locked together. This means that the rock and the soil erode at very different rates, and so the river gradient vastly differs over a short area, leading to an increase in stream velocity at a certain point.
All three of the features we just discussed can be linked to the stream discharge and topography of our streams. Cut banks are a feature found in meandering streams because of erosion by the tallweg. A stream usually meanders when it flows over flatter terrain like our site. Braiding and islands, in our case, can be found because of the features of our site. It's in the middle of a forest, meaning there's an excess of organic sediment. Also, it was actively precipitating when we visited Coalwood Creek, meaning that the stream discharge was higher than normal, potentially exacerbating braiding. Finally, nick points are completely based on stream topography, made when it abruptly changes. While Coalwood Creek normally had a very low gradient, at our waterfall the gradient was much steeper.
So in conclusion, we went to Coalwood Creek to see what we could see. What we found was a small meandering stream that had cut banks, nick points, and braiding, made because of the creek's topography and discharge patterns.
Even though we got rained on a lot, it was interesting to identify some of the technical terms from our lectures in our actual environment. A lot of these concepts are actually quite intuitive when you're looking straight at a stream.
Thank you for watching, gang. Make sure to smash that subscribe button and that like button. Okay, we'll catch you in the next video.